Howdy. This is another episode of Dinosaur Parkour. Faster, better mainframe programming. Thank you for watching. Today's topic is COBOL's evaluate verb. Specifically, evaluate a variable. I'm your host, Chris P. Fried. The examples were tested using IBM Enterprise COBOL 6.3. Evaluate variable replaces a series of nested if statements. Evaluate variable tests a variable against a series of values. The general term for what the evaluate does is a case or switch statement. It can also test multiple variables using the also clause. However, that will not be covered in this video. The evaluate true variation, which tests conditions, is covered in another video. This noisy slide shows 3 snippets of code. In the lower bottom left, it's a nested if statement, and above it is one example of how an evaluate can be used to replace those nested if statements. The evaluate is much easier to read and to understand than the nested if statement. Now granted, this example is a tad forced or not an ideal situation for nested if or the evaluate. If coding this for real, I prefer the single if statement in the third box on the right side. On later slides, the evaluate statement gets updated so that it does become a better example. The evaluate structure is composed of 2 parts: the variable to be evaluated, which is known as the selection subject, and the value to compare against that variable, which are known as selection object. Until recently, I was using the phrase selection value, and you might hear me say that still. I think the COBOL design group used selection object because the selection criteria can be more than simple value. Notice the evaluate WS number on the right side. Mathematical formulas can be used as selection object, so it's not just values. The when other clause is not required. This is different from other languages that have a case statement such as Java, C, or Rex, which require a catch-all clause to be coded. When I see an evaluate without a when other, I have to wonder if it was omitted on purpose or was it left off by mistake. My preference is that it should be coded, that way we know the programmer considered it. If WS character contains a 3 or a 7, the result is a message that says input is odd. However, when WS character contains a 4, nothing happened. Is that the design intention, or did the programmer forget to code the when other clause? This shows the same evaluate with the when other clause coded. The when other puts out a message that says input is even. Thus, when WS character contains 3 or 7, the message is input is odd. When WS character contains 4 or 8, the message is input is even. So far, good. If WS character contains the value of K, the message is input is even. Well, that's not correct. That begs the debate about whether the when other clause should be used for expected or unexpected result. I prefer the guideline to be the when other clause is generally used to handle unexpected results. Notice I said guideline, not standard. I do tend to favor that it be a standard that the when other clause must be coded and not omitted. That way all programmers coming after the original coder of the evaluate statement knows it's been considered. But I do not think that it should be a hard standard that it can only be used to handle unexpected results. There might be situations where using a when other to handle an expected result is the ideal way to handle a coding situation. This shows the evaluate where the when other handled an unexpected result. This is the more natural and normal use of the evaluate statement. The when clauses, or the selection object, are handling the expected result, and the when other handled the non-expected results. I want to back up a wee bit and talk about the why required a when other clause. This is a rather unusual reason for requiring the when other clause, but I think it's a valid one. When other can be a defense against human errors. First, notice the if statement at the top. That if statement ensures that WS character contains a value of 0 through 9. There are 10 when clauses or selection objects for 0 through 9. Therefore, the when other is logically not required. Since it does not perform a purpose, some programmers argue that it can be removed. Notice the storage area for something. It is located in working storage just prior to the location of WS character. Let's say that something is an IMS segment that was defined as 30 bytes. 2 months ago, it was expanded to be 60 bytes. The segment in the database has been updated, and the segment physically contains 60 bytes of data. This program should have been recompiled or changed, but it was not. Thus, the area for something in this program is still 30 bytes. The if statement executes. WS character contains a 6. That is a numeric value, so the if statement is false, thus no error. The read something paragraph is performed. IMS returns 60 bytes of data and overflows the storage reserved for something. The overflow fills into the storage that WS character occupied. Now WS character contains the letter A. Nothing logical about that. It contains the letter A because of a human error. This program should have been recompiled to pick up the expanded copybook, but was not. If the evaluate statement has when other clause coded to handle unexpected errors, the overflow issue is found the first time it occurred. In the real world, the when other was not coded, and the program processed without abandon for several weeks before the overflow issue was discovered. The solution for correcting the program was simple: recompile the program to pick up the changed copybook. That was the easy part. It took a couple of weeks to write an ad hoc program to undo the processing errors that occurred due to the overflow issue. This explains how making when other non-optional can help uncover human errors. Pretend that a change request has come in to change the two messages. That request might be worded: change the even and odd message to say what the input character is. The users or business folks do not know that the original programmer coded the message 5 times. They will be discussing the change as if there's only one message for even and a second message for odd. In the code, there are 5 lines for odd and 5 lines for even. Is there some way that the duplication could have been eliminated? Yes, by using set of when clauses or set of selection objects. There are implied ors between the when clauses: when 1 or when 3 or when 5 or when 7 or when 9. Display the message that the input is odd. Another way to word this is: the display that the input is odd is executed if any of the when clauses and the set of when clauses above it is true. Same statement applies to even numbers. Now add 2 when clauses to tell if the input is uppercase or lowercase alphabetic. The through clause can be used to test a range of contiguous values. The 2 new when clauses shown on the screen test uppercase A through uppercase Z, and the second one checks lowercase a through lowercase z. Some quick testing of the 2 new when clauses look good until the tilde symbol is pressed. For some reason, ZOS thinks the tilde is lowercase alphabetic. Well, that's strange. Why did that occur? To understand why, look at the exit copy on Wikipedia. This chart shows what are known as the invariant code point, or invariant character set. There are over 50 versions of the updated code pages. For the most part, the characters shown on this chart are in the same position across all of the versions. Notice the letters of the alphabet are not contiguous. The range of lowercase letters had the letters starting in code point hex 81 and ending in hex A9. The tilde is located at code point hex A1. The tilde appears on my keyboard in the upper left corner just before the number keys, the number 1 key. There are also several variable code points within the hex 81 through A9 range, but none of those appear on my keyboard. There are 2 other common fixed point characters that would be considered uppercase alphabetic for the uppercase A through Z range: the backslash at hex E0 and the closed curly brace at hex D0. The solution to our issue is to split the ranges as shown on this chart. Lowercase ranges are A through I, J through R, and S through Z. The same split for the uppercase letters. This slide shows the solution in the COBOL code. 3 sets of when clauses are needed to handle lowercase letters and 3 sets to handle uppercase letters. This slide has an error. This version of the Evaluate WS character attempts to state if the letter is uppercase or lowercase, with a second message if the letter is also a vowel. What happens when WS character contains lowercase e? The first when clauses are not true because they are for uppercase letters. The fourth when clause is true. The display E is lowercase alphabetic is executed. And process continued with the first statement after the end evaluate. The when clauses that check for vowels are not evaluated. They are never evaluated because one of the 6 preceding when clauses is always true. Every vowel is either an uppercase or a lowercase alphabetic. So those when clauses attest for the vowels and the display verb that follows them are unreachable code. I compiled this statement using COBOL 6.3 with a PTF level of 220314 using opt2, which triggers full optimization. I was curious if the compiler detected the unreachable when clauses and the display that followed. It did not. So this error is still dependent on the programmers and the testers catching it during code review or testing. I added a bit of hard code which triggered the warning about unreachable code. This shows the basic wording of the warning. The code from line 46.1 through 49.1 in the program test COBOL 01 was safely removed by the optimizer. The 46.1 mean line 46 verb 1. Back to the bad evaluate. There are several ways to correct the issue. One of the options is to add an also to the evaluation. However, I think the use of also makes the logic harder to follow. I can only remember using also once in a production program. I've coded also a few times, but I generally decide the code can be made more readable without it. This shows how I would correct the problem without using the also. It's by adding an if statement to detect the vowel condition. The evaluate is used to detect if WS character is alphabetic, and the if statement that follows checks if WS character contains a vowel. Thank you for listening to this video about evaluative variables. Please subscribe if you have not already done so. This has been another episode of Dinosaur Parkour. Faster, better mainframe programming.